Hello, class. Today I'm going to do a video Zoom recording for the COREC for statistics. This is COREC number 10, and it has to do with multiplying and dividing fractions. Okay, and so the first thing we're going to cover is multiplying fractions, and this is from your COREC portion of your workbook. And so we have some directions here that explains that to multiply fractions, you write the product of the numerators over the product of the denominators. So in math, product means to multiply. And so you see here they have these generic fractions a over b times c over d, and you can use the raised dot or the multiplication, the little x, okay? And so that you can see they're multiplying straight across a times c, b times d. That gives you a product of AC over BD. And it says that B and D, these should not equal 0. And the reason why is because uh, in math, we may not divide by 0. Okay, so like for example, if I write 4 over 0, and if I use my calculator just to show that, see if I take 4, then I divide it by 0. See how your calculator says there's an error, divide by 0, and it tells you to quit. Okay. And so if you set this up with long division, 4 divided by 0, usually with division, you have like a set of items, like an amount of marbles or quantity of items, and you're trying to break them up into groups. And this is usually set up by your divisor. So your divisor must be at least 1, and it must be a counting number. Like you're not allowed decimals, right? You're not allowed decimals for your divisor. So you've got to have counting numbers, and it should be at least the value of 1. And so 0 is not allowed. That's a whole number. Okay. And so if you want to break them up into groups, you have to have at least one group. Breaking up into groups, equal groups. And so we say that this is undefined. And then a quick way of remembering it is what it spells. Does it spell on or does it spell no? If you let 4 represent the number or the letter N for number, and you let 0 represent the letter O, so that will spell no. No. So no, you can't do this setup. Whereas if you had um, the other way, 0 over 4, okay, and I can do this in a calculator. 0 divided by 4, you see that's equal to 0. That is allowed. And this spells on. If you let the number 0 represent the letter O, and you let the number 4 represent the letter N, that spells on, like right on, right on, right on. You can do that math, okay? So thumbs up on that. Okay, so that's another way to learn that or memorize that if you don't want to use a calculator. Okay, so that's why they say here B and D cannot be 0. You're not allowed to have 0 in the denominator. Okay. Now, when they say simplify the resulting fraction if possible, uh, or you can say reduce if possible. So not everything is reducible, not everything is simplified. But if you do uh, uh, try to reduce Um, you can sometimes use the idea of cross canceling as well. And I'll show you some examples of that, an example of that in a little bit. Okay. Now an example of simplifying and reducing, let's say I had a negative 6 over 1. Okay. So this can be simplified. This can be simplified. That's just going to give me negative 6. That's an example of simplify. Okay, but if I have something like um, 12 over 8, that can be reduced. 4 is the greatest common divisor, or the greatest common factor. So you can see here that 12 divided by 4 is 3, and 8 divided by 4 is 2. So you can see how that reduces to 3/2, and that's actually an improper fraction. And if you wanted to make that a mixed number, you could by doing long division. If you do 3 divided by 2, the numerator, the top number, goes inside the house. 2 goes into 3 one time. 2 times 1 is 2. 3 minus 2 is 1r for one remainder. And then it gets recorded like this clockwise. So when you record that as a mixed number has this look to it, right? That's a mixed number. So the 1 goes in this whole space, whole number, and then the remainder 1 goes here as a new numerator, and then it's over 2, the denominator. So 3/2 is equal to 1 and 1/2, and that would be a mixed number. Okay. Okay, so if we look at the problems that are on this sheet, multiply 2/5 times 4/7. Okay, so I'm going to multiply straight across, and I'm going to reduce. Okay, so I'm going to say multiply straight across this way, and then reduce or simplify. Okay, so 2 times 4 is 8, and 5 times 7 is 35. And I don't think that can be reduced anywhere. I believe that's lowest terms already. There's not a greatest common factor except 1. When 1 doesn't count, that will divide evenly with a remainder of 0 into both 8 and 35. Okay. And sometimes you can see it when you try to reduce, you look, straight up and down, see if you can reduce that, and you also look diagonally, see if they have any greatest common factors, and this one doesn't. Okay. On B, negative 8 over 3 times 5. So I'm going to write this as 5 over 1. So I'm going to insert the 1, and I'm going to multiply straight across. So a negative 8 times 5 is a negative 40, and a 3 times 1 is 3. Okay, so this is negative 40 over 3, which is an improper fraction. And if you want to make that a mixed number, you could do long division. 40 goes inside the house, 40 divided by 3. And of course, this is a negative something. It's going to be a whole, see this setup, the negative whole number. Now we're trying to find the numerator. So how many 3's go into 40 without going over? So 3 goes into 4 one time. 3 times 1 is 3. 4 minus 3 is 1. Bring down the 0. And then how many 3's go into 10? About 3. 3 times 3 is 9. 10 minus 9 is 1r, one remainder. And remember, it goes, you want to record clockwise. So you want to record the mixed number clockwise, like by the movement of the clock. Okay, so you have this look here. Okay, so the 13 goes here, and just remember it's a negative. So it's negative 13, and then 1, and then over 3. Okay, and there's your mixed number. Okay, now I'm going to add another fraction at the bottom here. I'm going to do a problem that has 3 fractions in it. I'm going to call this C, and we're multiplying. Okay, so let's say you had 12 over 23 times 46 over 8 times 4 over 5. Okay, and then we want to figure out what that's equal to. Okay, so if you were to multiply straight across, you would get these really large numbers, and then you would have to try and reduce that. Okay, so we'll do that method first. That's the easiest one to teach. It just takes time to try and see what it's reduced by, the greatest common divisor. And on the test, I want you to reveal what the greatest common divisor is if it has it. Okay, so if I just multiply straight across, okay, so we start with 12 times, that's a big number, 46 times 4. And yikes, you get a big number, 2,208. You know it's even, so you know that can be reduced for sure by 2. Now you got to do the bottom. 23 times 8 times 5. And yikes, that's a big number too, 920. But you know these are even numbers, and so you know that even numbers, okay, even numbers in a 0 and a 2 and a 4 and a 6 and an 8, and you know that even numbers are divisible by 2. Okay, so you're safe with starting with that. So if I show that divided by 2, 2,208 divided by 2 is still a big number and still an even number, 1,104. And 920 divided by 2 is still a big number and it's still even, 460. Okay, so again, you know you can reduce again by 2. So 1,104 divided by 2, you're cutting it in at half, still even, 552. 460 divided by 2, 230. Okay, so now this can be reduced again by 2. These are still even numbers. So if I use my purple pen here, and I'm going to show divided by 2. And let's see, go this way, see what that's equal to. So half of 552. 552 divided by 2 is 276. And 230 divided by 2 is 115. All right. So now, let's see. Where's my look at whiteout? Okay. Just erase this here. Fix this here. Okay, so now you know this is not reduced by 2 again because this is not an even number. And this is, but maybe we can reduce it by something else, like maybe 3 might work. So I'm going to just try it. Is it divisible by 3? And I'm just put like a question mark on it. Where's try? 276 divided by 3. Okay, let's see if 115 works. 115 divided by 3. Nope. See how I get a decimal? Yeah, so 3 doesn't work. Okay. 3 doesn't work. Okay. Okay, so let me look at 115. I know with divisibility rules, if a number ends in a 5 or if a number ends in a 0, I know 5 will work. So I know 115 divided by 5, I know that will give you 23, which happens to be a prime number. So 5 goes into that. Now 5 doesn't go into this number 276 because it has in the 5. But I know 5 times 23 is 115, and those are both prime, right? 5 and 23 are prime. So maybe if something does work, maybe 223 works. Maybe 276 is divisible by 23. So we'll just try it. 276 divided by 23. Well, look at that. It does work. Okay. So it looks like this can be reduced by 23. So 3 didn't work, but it looks like 23 does work. So let me just try that again. That would be the greatest common divisor, the greatest common factor. Okay. So 276 divided by 23 is 12. And 115 divided by 23, is 5. Yeah, and then that doesn't look like that can be reduced anymore. That's 12 over 5. But you can make that into a mixed number. If you do 12 divided by 5, 5 goes into 12 twice. 5 times 2 is 10. 12 minus 10 is 2r. And then it goes clockwise like this. So this is equal to 2 and 2/5. So that would be the mixed number. Your mixed number. And 12/5, that's the improper fraction. Okay. So 12 over 5th is the improper fraction, and 2 and 2/5 is the mixed number. Okay. Now, so it's good to be able to reduce right on your own. Now, you know from chapter 4 in the calculators TI-84s and the probability chapter, we do have a math frac key. So if I go back to that and just double check what we did, you would still need to multiply across straight and get these big numbers, and then you would divide 2,208 divided by 920. That gives you this decimal 2.4, which makes sense. See, 2 and 2/5, that's where the 0.4 comes from this. See, if I do 2 divided by 5, there's my 0.4. So it's 2.4. So that's 2/5 is equivalent to 0.4. Okay. So if I go back and do 2,208 divided by 920, and I get the decimal equivalency, and then I hit my math button, and then I hit that frac, see right there, frac. So I just hit enter, hit enter on the calculator, just down here, and then hit enter again. And then see how that reduces to 12/5, which is what we got here on our own, dividing it out ourselves. Okay, so it's good to know how to do it on the calculator too, to check your work. So we also used, you can apply math and then frac, and then enter, enter. Okay. Okay, now let's see. If I rework this problem, breaking these down into prime factorizations. Let me also show you that. You might like that. That'd be good to show you that. Let's see. Let's say I have if I break the numerators and denominators into their prime factorizations. Let me show you that. So like 12. So like what two numbers can you multiply and get 12 besides the trivial 1 times 12? So like 12 is even number, so you could break it down with twos. 2 times 6 is 12. So I circle my prime number. 2 is prime, but I don't circle 6. 6 is composite. A number is either prime or composite. It can never be both. So 6 is composite, which means that it can be broken down. Besides 1 times 6, it's 2 times 3. Okay, so 12 is 2 times 2 times 3. And I can check that. 2 times 2 times 3. So 2 times 2 is 4, and 4 times 3 is 12. Okay, so I don't need 6 in there at all to compute that with 12. Okay, so now I know that 12 can become 2 times 2 times 3. Okay, now 23 is a prime number, and I think I've shown you before in our curriculum the list of primes. I think I've shown you like on oftentimes on the back of a multiplication chart. I always have this list of primes, and 23 is actually a prime number. Remember, a number is either prime or composite. So 23 is a prime number. Only 1 times 23 is 23, and you cannot break it down with counting numbers, you know, not using fractions or decimals, just a counting number times a counting number. So just 1 times 23 is 22. That's prime. So this will stay the same. Okay, now 46 can be broken down by 2. So 46 divided by 2 is 23, half of 46. So 2 is prime. And you know, and so is 23. We talked about that a while ago. We saw that on the blue sheet a while ago. We saw how 23 is on here. It's a prime number. So 46 can be broken down into 2 times 23. And 8 can become 2 times 4, and 4 can become 2 times 2. So you have 2 times 2 times 2. And 4 is just 2 times 2. And then 5 is prime. 5 cannot be broken down, and 5 is a prime number. Okay. Okay, so now when I try to cancel, when I try to cancel, so I break the numbers, numerators and denominators into the prime factorization. So I did that. Okay, and then now I'm going to cancel out like factors to reduce. And when we cancel, you can, what's allowed is you can cancel like factors up and down or diagonally. Okay, but never cancel out straight across, because you multiply straight across. So never try to cancel out, straight across. And that's because what we do is we multiply straight across. So you look at your, if you look at your problem over here at the top, what we have here, and you want to try and cancel out first up and down. Let me see. Okay, let's see, up and down. So if I look up and down, nothing like up and down. Oh, here's something. See this 2 and that 2? Okay, up and down, nothing. Okay. Okay, then I can try and cancel out this way, diagonally. So like, for example, this 2 and that 2 cancels out. 2 goes into 2. And this 2 and this 2 can cancel out. These are like factors. Anything else? What about the 23s? See this 23? That's kind of canceling this way, diagonally this way. So and I think that's it. I think that's all the canceling out you can do. Okay, so then the next thing you want to do is you want to refresh, and so now you have what you really have now is you have 3 over 1 times 1 over 1. Those are all gone. Basically, they're all gone. And then 2 times 2. 2 times 2 is 4. So you could go ahead and put 4 if you want over 5. So you're refreshing it. So you have 3 over 1, 1 over 1, and this is really 4 over 5. So you refresh that page, okay? And now you can multiply straight across. So you refresh that page, update it, refresh it, you update it. And then you multiply straight across. this way. Okay, so if I try that now, see what I have. Now I have 3 times 1, which is 3, times 4, which is 12. 1 times 1 is 1. And 1 times 5, excuse me, is 5. So now you have 12 over 5. And isn't that what we got over here when we were reducing it on our own? Didn't we do this? We kept reducing it by 2 and 2 and then 23, and we got 12 over 5. Okay. All right. So see what's on the next page now. Okay, so hopefully you got that written down, and let's check out the next page. You can always pause the video. You just need more time. Okay, so multiply and simplify fractions. So multiply the fractions and simplify if possible. Okay. So if I just start by multiply straight across, excuse me, 4 times 5 is 20. And 30 times 14 is 420. And then, in zeros, if a number ends in 0, numbers that end in 0 are divisible by 10. That means that 10 will go into it with a remainder 0. So you can do this by 10. And you can also cross out these zeros, these end zeros, cross them out, and you'll see that you get 2 over 42. So let me show you. 20 divided by 10 is 2. 420 divided by 10 is 42. So you see, if you were to cross those end zeros out, if you were to say 20 over 420, and you were to cross out these end zeros here, then you would say that you end up with 2 over 42. Okay, excuse me. Okay, and then these are still even numbers, so you can still reduce by 2. 2 divided by 2 is 1, and 42 divided by 2 is 21. Okay, so it's 2 divided by 2 is 1, and that 2 goes into 42 21 times. Okay. Again, if I were to double check with MathFrac, 20 divided by 420 is this decimal, and then I'm going to do math and then frac and then enter. See, I'll get 1 over 21. So you should check your work. So on the test, I'll ask you that you can check your work using your calculator when we take our tests over all these corrects, but then you want to show your work. So I want to see on the correct test doing some of this by hand so that I know you know how to reduce. And then you check your work on the calculator to make sure you get it right. Okay, the bottom, multiply and simplify these fractions. 10 over 18, it's negative, times, there's another negative, 21 over negative, that's 55. This is a negative number times a negative number. Okay, so first of all, a negative times a negative is equal to a positive result. Just to make sure everybody remembers that. Negative times a negative is a positive. That's important. And, they use parentheses, but Um, they can also have used the raised dot, and this negative could go on top, right, or in the middle. And they could have used the raised dot, or they could have used the little times. These little times here. Okay. And most teachers just put the negative at the top. If you put them at the bottom, they're concerned you're going to forget about it. So most of them just rewrite it at the top if it allows that. Okay, so if I start multiplying across, I have 10 times 21. It's actually, excuse me, a negative times a negative. So let me go back. Negative times a negative is a positive. So negative 10 times negative 21 is actually a positive 210. So it's still positive. Negative times a negative is a positive. And on the bottom, I have 18 times 55. Well, that's a big number, 990. Okay. And then, you can mark out these end zeros. You know that if I can also say I'm reducing by 10. If I knock out these end zeros, that looks like I get 21. Or let's see, if I knock out those end zeros, yeah, 21 over 99. And let's double check that. If I do 21, no, 210, 210 divided by 10 gives me the 21. 990 divided by the 10 is 99. Yeah, so that checks out. So I'm reducing greatest common divisor here. And I think 3 will go into this. If I reduce this by 3, 21 divided by 3 is 7. 99 divided by 3 is 33. Okay. 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 All right. Okay. All right, class. So you're all right with that? And if I use my calculator and on 210 divided by 990, there's your decimal repeating a bar over 0.21. Let me just show you that here, how to write that, the bar over the digits or digits that repeat. 0.21 repeats. But if I do math frac on that, math, and then frac, and then enter, 7 over 33, yeah, which is what I have here. Okay. Okay, so now we're going to divide fractions, okay? I think what we do for this one too is I think I'll just put the decimal equivalency for this one since I did that for the bottom one. 1 divided by 21. Oh, it's super long though. Look how long that is. Yeah, so I think on Connect Math, I don't think they will allow decimals. I think they'll usually allow decimals if the problem starts off with decimals, but the problem starts off with fractions, so I don't think they'll ask you to make it a decimal. But if they do, make sure you're up to par with your, calculator, your steps and everything for that. Reducing them, things like that, your calculator commands. All right. Okay, sorry. Let's do the division. Sorry, let's do the division. To divide fractions, it says, let me make this larger. It's really light. Let's see. This part is really light. To divide two fractions, multiply the dividend. And which one is the dividend? They're telling you it's the first fraction. Uh, by the reciprocal of the divisor. And which one's the divisor? To tell you that's the second fraction. Okay, so also in your parts for division, long division, this is the dividend also. This is the divisor. The answer you get at the top is called the quotient. Then your remainder is often down here somewhere. Down here R, the remainder you're left over, if any. Okay, but those are your dividend, divisor, quotient. So to divide two fractions, we multiply the dividend by the reciprocal, the second of the divisor, the second fraction, okay? Okay, in your picture, see what I can, if I can read what it says here. Change division to multiplication. So we're talking about this, change this division into a raised dot multiplication. Take the reciprocal of the divisor. Yeah, so the reciprocal of C over D is D over C. So reciprocal, you're just flipping it. You're just flipping it. You're just flipping it. So let me say flip it. Let me say that instead. Flip it. You're just flipping it. You're not taking the opposite. You're not changing the sign. You're not flipping it and changing the sign. You're just flipping it. So the reciprocal of C over D is D over C, and that's what they're doing. Multiplying by the reciprocal. And they're saying that B, C, and D cannot be zero. Yeah, because if you let B or C or even D, this one, even D be zero, no number is divisible by 2. So you're only weakening your steps. We're not allowed to divide by 0. So B, C, and D cannot be 0. Okay. Okay. Okay, let's go to the bottom. Dividing and simplifying it possible. So let's just practice that. So we have 2/5. So oftentimes teachers say this, keep, change, flip. So you keep the 2/5, change a division to a times, and then you flip. If you flip 7 over 4, you get 4 over 7. Okay, and then now we have, let me see, note. Now we have multiplication of two fractions. Okay, so now it's like the lesson that we just did on the previous pages, everything that we talked about here, these previous pages that we were doing, we're multiplying fractions. So basically you can multiply straight across and then you try to reduce. 2 times 4 is 8. 5 times 7 is 35. Now I don't think that can be reduced. I think that's already lowest. terms already. Okay. All right. And then on B, again, keep, change, and flip. So again, keep, 2 over 27, and then change the division to times, and then flip. Negative 18 over 15 is now negative, still negative, but now 8 over 15 becomes 15 over 8, so you flip, and it's still negative. Okay, you don't change the sign, you just flip it. Okay, now you want to multiply straight across. So those are kind of big numbers. So let's see if I do 2 times a negative 15, it's a negative 30. And that's a big number here. 27 times 8, yep, it's 216. Okay, and these are even numbers. Even numbers are divisible by 2. So negative 30 divided by 2 is a negative 15, and 216 divided by 2 is 108. So you know that can be reduced again by 2, because this is not an even number, but let's try 3. Let's see if is this reducible by 3. Let's see. Negative 15 divided by 3. So that looks good. No decimals. Okay. 108 divided by 3. Oh, that looks good too. That's 36. So negative 15 divided by 3 is negative 5. And 108 divided by 3 is 36. Okay, let me just scoot this down a little bit. Okay. And yeah, that can't be reduced anymore. And then if you're gonna check, you can I'm gonna say compute by hand, right? So compute by hand, and then check using TI-84, and we're talking about the math, and then the frac, and then the enter, that talk about that. So if I check this here, I can go all the way back up to this one, the negative 30 divided by 216. See that decimal? So this is actually equal to a negative 0.13 8 with a bar over it. See all those repeating 8s? So a bar over that means the 8s. The bar is only over the 8. Okay, now I'm going to do math, and then frac. So hit enter, and then hit enter again. That's what this is saying. And see, I get negative 5 over 36. So it checks out. So you should show your work on the test for this co-rec. You want to show your work on paper, but then you can go back and now you say use your calculator as a tool to check your work. Okay, and then there is one more page, and then I do have, in addition to this last page, I do have uh, three application problems to show you. And there is one application problem on here, just one, but I have three more that I got from Connect Math that I'll show you. Okay, let me get this sheet of paper. Okay, so here we go with 35 over 14 divided by 7. Okay, so we said we're going to keep the 35 over 14. You're going to change the division to a times, and then you're going to flip. So this is 7 over 1. So now this is 1 over 7. Okay. And so now, so keep, change, and flip. Okay, now multiply straight across. So 35 times, we can do this. Okay, 35 times 1 is 35, and 14 times 7 is a big number, that is 98. And then let's see if that can be reduced. So 2 won't work because that's not even. And I don't think 3 will work. If I do 35 divided by 3, that doesn't work. And I know 5 will go into 35, but I don't think, let's see, 35 divided by 5 is 7. So I know 5 doesn't work, but I don't think 5 doesn't go into 98 because it doesn't end in a 0 or a 5. If a number ends in 0 or 5, then you can reduce it by 5. But maybe 7 will work because 5 goes into 35 7 times. So maybe 7 will work. Let's see. So 35 divided by 7, that looks good. 98 divided by 7. Yep, that looks good. So when you do that, it has to be the same number. You're dividing the numerator and denominator by the same number. So this works as the greatest common divisor, the greatest common factor. So 35 divided by 7 is 5, and 98 divided by 7 is 14. But then after that, that cannot be reduced anymore. Okay. And it does say write your answer as a fraction. Yeah, so we'll leave it. I'm not going to put the decimal equivalents on that. Okay. Okay, and then B, I'm going to write this over 1. Okay, so then this is keep, change, flip, right? So keep that as negative 12 over 1. Change the division to a times, and then flip. So it's still going to be still negative. You're going to flip it and it's still negative, but it's going to be 3 over 8. Okay, and then I'm going to multiply straight across. So negative 12 times negative 3 is 36, and then 1 times 8 is 8. Okay. And those can be reduced by 2. These are even numbers. So even numbers are divisible by 2. You're safe by 2. So 36 divided by 2 is 18. And 8 divided by 2 is 4. And again, even numbers are divisible by 2, so that can reduce that again by 2. 18 divided by 2 is 9. And 4 divided by 2 is 2. So it looks like that's 9/2. Okay, and that's an improper fraction. That's an improper fraction. If they want it as a mixed number, and they didn't say it had to be a mixed number, it just said write it as a fraction, but it has to be reduced. That goes without saying. You can't just say you can't just say it's 36 over 8 and you stop there. It goes without saying it has to be reduced. But they didn't say it had to be a mixed number. Mixed number looks like this. But it didn't say it couldn't be. If you wanted to, you could. You just have to do long division. So 9 divided by 2. Remember, the numerator goes inside the house. So top goes inside. And 2 goes into that about 4 times. 2 times 4 is 8. And 9 minus 8 is 1r, 1 remainder. And it goes clockwise. So it looks like you have 4.5. 4.5. Okay. All right, let's look at your applications. So I'm going to show you this application, and then I do have, I'm going to write down, I got some from your system, your platform. I think I have 3 that I got from your platform that have applications. So you're either going to be multiplying or dividing. So there's some keywords that we can use to help you with that. So here, this is helpful, the title, because it's an application, it's a story problem, and they're giving you a hint. See, they're going to tell you you're going to use division. So usually when you read these problems, you're not sure, like, do I have to multiply or do I have to divide? Okay. So, I mean, you and chances are if you do the problem and you get it wrong, if you do an application problem and you get it wrong, you feel comfortable that your your structure of the work is your work is correct. If you get it wrong, then maybe you're supposed to divide. Maybe you're supposed to divide, and then you just then you then you do it again with division. But you want to look for keywords to help you with that. So a 9/4 foot length of wire must be cut into pieces of equal length. So if you imagine, you have some kind of a wire here, your wire, okay, and it's got to be cut into equal lengths that are 3/8 feet long, okay, and that's small, right? 3/8, 3/8, 3 divided by 8. So it's not even half. If you had 4 divided by 8, that would be zero point 0.5. So it's small. It's a small piece, 0.375. So it's small pieces. So you want to cut into 3/8. So you want to, this is going to be 3/8, and then this is going to be 3/8, and then this is going to be 3/8. And then you get the idea. I'm going to do dot, 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 so on and so on, and until you get to the end, right? You get to the end of your wire here. Okay. So you just don't know how many pieces, right? How many pieces can be cut? You just don't know. So um so to find your answer, you want to use division. You want to use division. You want to divide this into equal pieces. Now here, I mean, do you have a keyword? I mean, maybe the keyword could be the equal lengths. Maybe that's a keyword maybe for division. You want these equal lengths. Maybe it's a keyword for division, maybe equal lengths. And so the idea is that, oh, and they told you that the whole length, they said that, you know, from here to here, they said that was 9/4 feet. They told you that was 9/4 feet. That's the whole length, right? So from here to here. Okay. So if you take your entire length and then you divide it by the equal segments length. So we're going to use division. And then that's another thing is, okay, we're going to use division, but then what goes first? How do we set it up? A number divided by another number. What goes first? So you want to put your entire length first, which would be the 9/4. And this is in feet. And then you're going to divide it by the equal segment, equal segments length. And these are 3/8. And this is also same measurements, also feet. So that's good. You need to have the same units. Otherwise, you'd have to do some conversions. So we already have the same units. So we're basically working with 9/4 divided by 3/8. Okay. So the idea is um, you have your 9/4 and you're dividing it by 3/8. This is like your divisor. How many of these groups, see, how many of these groups can you make out of this whole length here? Okay. So this is our setup. So we're going to keep, let's be 9/4, and then you're going to change. You're going to change that division to times, and then you're going to flip. So you flip 3/8, you get 8/3. Okay. And then you just can multiply straight across and then reduce. So 9 times 8 is 72. And then 4 times 3 is 12. Okay. And feet divided by feet, the feet will cross out. So this is like 9 times 8, this is feet over feet. And basically your feet cancel out, and then you're left with how many pieces. And let's see what 72 divided by 6 is. 72 divided by 6 is 12. 72 divided by 12, excuse me. 72 divided by 12. 6. 6 pieces. So how many pieces can be cut? Six pieces can be cut. Okay. So that's an example of division that's needed. Okay, now these next two examples I'm going to show you are examples of multiplication being needed. So I have to write these on a sheet of paper. Okay, so I'm going to say, let's see how they worded it. They worded it using, I'm going to say using multiplication in an application. Okay, so it says that I'm going to say Gabriel decides to save 1/7 of his pay each month. Okay, and then it says if his monthly pay is $4,410, comma, how much will he save each month? Okay, there's your problem. So I would say here that a keyword would be this part of of his pay. And in math, the word of can mean to multiply. The keyword of can mean to multiply. So he decides to save 1/7 of his pay each month. Okay. If if his monthly pay is 4,410, how much will he save each month? So yeah, we can take the 1/7, okay, of the pay. So I guess I should say save of pay. How much does he decide to save? So something like savings of pay. So the savings is 1/7 of, and then the pay is 4,410. And then you can write this you can write this over 1. Okay, and then you can multiply straight across. So 1 times 4,410 is 4,410, and 7 times 1 is 7. And then if we divide, I bet that goes into that evenly. Let's see. 4,410 divided by 7 is 630. Yep. So how much will he save each month? Yes, he's gonna put away 630. This is monthly. I can say monthly savings. That's good. That's a good amount. Okay, so putting that away. All right. Yeah. So in a year times 12, putting that much away in a year. So I always say when you're trying to save money, like in your retirement, time is your friend. So as soon as you start working and you start saving, putting that money away, time is your friend. That starts building up and accruing interest. Okay, and then as it gets a larger and larger amount as you get older and you work longer, it starts accumulating interest, and then you'll be satisfied with what you reap right from your savings. Okay, so time is your friend on that. So that's good to save early, begin early with that. Okay, now there is another problem. Let me see me do this. Also using multiplication in an application. Let's do this problem here. And this is EX, for example. So we do another EX, for example. Let's say Sylvia had only enough paper, to print out 2/3 of her book report before school. So she cannot print all of it. She prints most of it, but not all of it, because 2 divided by 3, it's about 67%. Okay, I do times 100 percentage, about 66, 67%. And if you had 3/3, she'd have the whole paper printed out. So she's got almost 2/3 of it, right? Most of it's almost printed out. So it wants to know if the report is 12 pages long. They want to know how many pages did she print out. So if the report is 12 pages long, how many pages did she print out? Okay. So again, if I look for a keyword, this part of again, of her book report. So I would say that's a keyword again, in math, of means to multiply. Okay. Okay, so here we've got her printout. She had her printout, which was 2/3. She had her printout of, and then her actual book report. So her printout was 2/3 times her book report was actually 12 pages. Okay. So I'm going to write that as 12/1. And then I'm going to multiply straight across. So 12 times 2 is 26, right? Or no, 24. Sorry, 24. 2 times 2 is 4. And then 3 times 1 is 3. And then I think that will go into it evenly. If I do 24 divided by 3, that goes into it 8 times. Okay. And this is how many pages does she print out? So this is 8 pages of the 8 pages were printed out. So 8 pages. How many pages? How many pages? So does she print out? 8 pages are printed out. Okay, guys. One last problem. Okay. Okay, this last one is going to use, we're going to be using division in an application. Okay, let's see what this one says. This one says, Tiffany has a 5/7 inch nail that she must hammer into a board, and each strike of the hammer moves the nail 1/21 inches into the board. How many strikes of the hammer must she make to drive the nail completely into the board? And then that's a question mark. Okay, it's a minute to write that down. Okay, then gives you a minute to kind of visualize that. I'm also looking at the other problem that we did about the 9/4. I'm also trying to see we find any keywords like we did this one earlier. This one was a division problem also. Yeah, and then it'd be hard to draw a picture, but you have a board, and then you have this, this nail. You're trying to hammer that nail into the board. Okay. So every time you hit that hammer, it drives it in deeper into the board. It moves it. The nail moves the nail 1/21 inches into the board. So you want to know how many times, right? How many strikes, how many times we have to strike it so that It's driven completely into the board. Okay. And these are, equal lengths, 1 over 21 equal lengths that go deeper and deeper into the board. So I guess if I had to draw a picture every time you drive it in, every time you drive it in, that's 1 over 21 of an inch that you drive it in. It goes deeper and deeper into the board. And I think, what could be considered a keyword is also in math that sometimes the word each can be considered a keyword. So I would say that each is a keyword for division. And again, if we set this up, the idea of you divide, it's like the larger amount divided by your smaller amount. So you want to take the nail's length and then you want to divide the nail's length. You're going to use division for each strike, like per strike, per, each strike, per strike, each strike. So sometimes the word per means division also sometimes, okay? And so, and again, it's like, 5, 7 is if you're not sure which one to go first, also 5 divided by 7 is about 0.71, whereas 1 divided by 21 is small. See, 0.04. So yeah, the idea is you usually do your larger number and then you divide it by this smaller number. That's kind of helpful too. So your nail is 5/7 and you're dividing it by that smaller piece, 1 over 21. Okay. And when we did this other problem over here, when we have this wire and we were cutting into equal pieces, how many pieces can be cut? The 9/4 was larger, right? 9 divided by 4 is 2 point something, and 3 divided by 8 is smaller, 0.375. Yeah, so this was like the larger number divided by the smaller number also. I didn't point that out, but sometimes that can be helpful because sometimes people don't know they know to divide, but they're not sure which one to put first. Okay. And then again, if I set it up this way, the 5/7 and you're dividing it by the 1 over 21. So this is the divisor. So sometimes that also helps. So yeah, like over here, this was the divisor. Okay. Yeah, I don't see any more keywords. I was looking for equal. I don't see the word equal in here. Okay, so then we keep and then we change and then we flip. And then we just multiply across. Yeah. And so and this is fine. If you go this way, you can go that way also. That's fine. Or you can keep working down. It's also okay. 5 times 21 is 105. And 7 times 1 is 7. And let's see if that goes, I'm sure that goes into it evenly. Let's see, 105 divided by 7. Yep, 15 times. So this is 15 strikes. So you got a hammer 15 times. It's quite a bit of time. Yeah, 15 times, 15 strikes. And then nail will be that nail will be into the board. Okay. All right. All right, class. That concludes the correc. All right, for correc number 10. So there are like 11 different correcs, and then they have a we have a test. They have a test. The curriculum committee, have a test scheduled for you after the co-recs are done. Okay, so it would be good to do the practice. There's a practice test set up in Connect Math, and so we should have that done first, and then take a practice test, and then then you do the test and respond to monitor would be the idea. Okay. All right, so complete your online homeworks for the co-rec, do them for completion and of course for understanding, so that when you take your tests, you can understand what you're working on. Okay. All right, good luck with that. Take care.